Alright, in this video we're going to be looking at section 3.4, comparing two beans. Okay, I'm just going to roll with this. So here are some beans, maybe kidney beans. So they got some kind of hole here, I'm seeing. Don't know what's going on there. Nice mahogany color. This is weird. Oh, it's means. Oh, comparing two means. This makes more sense. So in this section, we're going to be comparing two means. Different than anything we've done before, we have been focusing on one variable at a time, taking a statistic from a sample, and then just focusing on doing a hypothesis test around that one idea. Is the average equal to this? Is the proportion equal to this? And then that's been everything we've done so far. But now what we're going to do is we're actually going to have two means that we're going to be comparing and saying, instead of is one mean equal to a number, we're going to take two different means, possibly, and we're going to try to compare those. In the next section, we're going to do two proportions. So there's a little setup we have to do here, just because I keep saying two means, but what is that? What am I trying to say there? So here's a population we're going to call A, and then completely separate from this population, we've got another one here called population B. Okay, so these are two separate populations. Sometimes you'll see the word independent. They are separate. There's no crossover between these two groups, okay? Right, so the very common thing you'll see, and there's an example of this in the book, is you'll see this broken up by sex. So you might see this as men, some group of men. You could figure out the age you want to talk about. In the book, there's the example of children between 7 and 12. And then this is women. So we're breaking it up by sex, and these are the two groups. Okay. So when you have these two groups, often you might want to ask a question. Let me learn about one and compare it to the other. So, we could do lots and lots of things here with means. For example, we could ask the question, just to be interested in, what's the average height of women? But we could also ask that, what's the average height of men? And so far in this class, we've actually, we've done okay separating this and answer just for the women. We know how to do that, right? We want to know about maybe all adult women in the U.S. We take a sample, we can do a hypothesis test, try to see if our sample is, it's plausible that we hit some value. Maybe we looked up however we got that value for the hypothesis. And then separately, we could do the same thing for men. But now we want to, instead of doing that, we want to compare them. So we want to take the average height of these women and see if there's some kind of comparison we can do to men. So the question we're going to be asking ourselves is something like, is there a difference in the average height of men, and average height of women? So, that's a type of question we could ask. And what's key here is that you don't need to think of this as some crazy new thing. Break down this sentence we just wrote here, and what you have to see it for is it's almost like two copies of what we've already done. Because we've already tried to explore the average height of women, that idea, right? That's something we've already kind of thought through. So how have we represented that? Well, we represented that with mu because it's average, and then I'm just going to put a W here for women. So I'm asking, is there a difference between these things, between these two groups, these two populations? And in math, how we do that, trying to find a difference, is we subtract them. So we're just going to subtract these two things. And then, we kind of want to know what happens. So is there a difference between them? Now, if there is a difference, we got to get our math gears grinding, our algebra gears grinding a little bit. If there is no difference between these two, then this will be 0. The difference between them will be 0 if there's no difference. Sounds a little silly just saying it out loud like that, but it's important that there will be a 0 difference between them. What's another way of rewriting that, though? Because maybe you're kind of thinking like, oh, that's weird to say. Well, another way to rewrite no difference is to say that the average height of women is equal to the average height of men. Right? No difference means they're equal. Okay? So we're interested in finding out if there is a difference. But just like before, we are interested in finding out if our die, right? Remember rolling die. If our die was, rolling 6s too much or 1s too much, it was not fair. We were interested in that. But the way we figured that out was by first assuming, nope, it's a fair die, boring. And how do we do that? We said, okay, well, that would mean the die will roll 6s in the long run equal to 1/6. We were able to put a number on it in the specific scenario of fair. That's what we're going to do here. If there's a difference between men and women's heights, it could be a lot of stuff, right? They could be 1 foot, 2 feet, 1 inch, 3 inches, all these different numbers. But if there's no difference in their heights, that's only one number, 0. So just like before, we're really interested in a difference, but maybe we can't get there. And so instead of that, what we're going to do is we're going to assume there's no difference and see if we can apply some of the previous ideas that we had in hypothesis testing to this.